sorry, having too much fun with this. But hopefully you enjoyed that. We have to start with a little bit of fun to get us going, a little bit of mirror action going on here. Let me go ahead and pull up our presentation for today. Hopefully we're all doing well, still surviving this craziness that is the coronavirus happening. Today we're going to have, I think, a little bit shorter of a video, and I think this is a little bit easier than what we've been doing in the past. The last two lessons were, well, especially the partial fraction decomposition, I imagine, is a little challenging for a lot of us. Also, that first lesson, there was just a lot that we did, right? The solving systems of equations. This should be fairly reviewed. There's just a little bit of a twist that we're throwing in here from, I don't think you've done this before, but it should come very natural from what we've been doing, okay? So I think you're in for a little bit of a shorter video today, and I hope it'll be a little bit easier to do. So what we're going to be looking at today is section 5.4, which is nonlinear systems of equations, okay? So I'll talk about kind of what that means in a second, but essentially what we are doing here is before, in the first couple of sections, we had looked at finding intersections of lines, right? And then in the second section of planes, right? Really nice things where there's not any curviness to them at all. They're all very flat and straight. So what we're doing today is, can we find intersections when there is curviness going on, right? So I have here on Desmos' graph, I have two separate equations. One is y equals x squared plus 2. The other is negative x plus 2. So this one's the line, the blue one's the line, and the red one is a parabola, right? And we wonder now, well, can we find these intersection points? Can we find out where these cross each other, okay? And this is called a nonlinear system of equations because of this parabola here. It's not a line, right? So it's nonlinear. So we're looking for intersections now where we're not just dealing with lines, okay? And you'll find actually that the techniques for solving these are pretty similar to what we did for linear equations. We still use the same methods for going about this. It's just we have to adjust a little bit to make this work correctly, okay? So I am going to just briefly talk about how do we tell if a system is nonlinear? Okay, kind of what's the difference between a linear system and a nonlinear system? Okay, so an example of a linear system is something like this. 5x plus 7y is 2, and 3x minus 4y is 7. Okay, you'll notice the x's and y's only have powers of 1. Okay, so x and y in this system only have powers of 1. Okay, so this is why it's a linear system. And even the 3 variable ones we did with z's, if the z only has a power of 1 on it as well, we still consider it a linear system. So what would a nonlinear system be? It would be something where you don't have powers of 1 on your variables anymore. So for instance, I could do x squared plus 2y is equal to 7, and I could do 3x minus 2y is 4. Now you'll notice just this one is linear, right? But this one is not linear. And so in order to be a linear system, all the equations have to be linear. not just 1, okay? So whenever you have a power bigger than 1 in your system on one of the variables, it's a nonlinear system, okay? So let's look at an example here. So let's say that I have this system here. X squared plus y squared is equal to 100, okay? Now what does that look like graphically? Well, if you have x squared and y squared plus each other, that's going to be a circle of radius 10, actually. If you kind of remember doing circles from a long time ago. This is actually a circle. I'll show you the graph in a second once we solve this out. And then this equation here, well, there's only powers of 1 on x and y, so this is going to be a line, okay? So I have a circle and a line, and I'm trying to figure out where do they touch, okay? What values of x and y do they touch at, okay? So, how we do this? We can still use the 2 methods that we talked about for linear systems. Substitution and elimination, okay? So on this one, I'm going to demonstrate substitution, okay? And I think it works a little bit better than elimination because x and y in this equation, there's not really an x squared that I can cancel out with this x squared down here, right? And so I think generally substitution would be what you would want to do here, okay? So, substitution, what are my steps? I'm going to solve one of the equations for one of the variables. And if I were to use this equation, I'm going to have squares in it, right? And so it's harder to solve. This equation is nice. So I'm going to solve that for one of the variables, okay? It doesn't really matter which one I use. Let's maybe just solve for y, okay? So step 1. Solve for a variable, okay? So I'm going to solve for a variable in here. I'm maybe going to do y, okay? So I'm going to minus my 3x over. I get negative y is 10 minus 3x, just subtracting over that 3x. And then to get y alone, I'll just times by a negative, or divide by a negative if you prefer. That will just switch both of those signs, okay? So I now have an equation for y, okay? I've completed step 1. I've solved for one of the variables. Then what I'm going to do, step 2 was to plug in that equation into the other equation. Or to just simplify that down, I'm just going to substitute. Okay? I'm just going to substitute in this equation here for y in the other equation. So I've got x squared plus negative 10, or sorry, negative 10 plus 3x squared, okay? So this is x squared plus y squared, right? But y is this, so I just plug that in for y is equal to 100, okay? So now I have an equation with one variable, right? So I can solve for that variable. That leads us to our last step here. Step 3, solve for the variable. Okay. So let's go ahead and solve this. How am I going to do that? Well, I have a square here over this whole thing. So I should distribute this out, okay? So I'm going to have still an x squared here. And then I'm going to have, for the square part, let's say negative 10 plus 3x and times a negative 10 plus 3x, right? That's the same thing as squaring it. You're just timesing by itself. So then we can FOIL this out, or Santa hat if you prefer. We would get x squared plus negative 10 times negative 10 is 100. So we've done those two. Then negative 10 times positive 3 is negative 30x. So that's there, okay? And then 3x times negative 10 is negative 30x. And then 3x times 3x is 9x squared, and this all equals 100. Okay? So I'm just multiplying this out so that I can get an equation to solve for x. Okay? So, now what do I do here? Well, we can simplify things a little bit, right? I have a x squared and a 9x squared, so that's going to give me 10x squared. Okay. I've got a two negative 30x's, so that's negative 60x's. Okay. And then I've got this plus 100 on this side. Okay, just combining up like things, this should equal 100. Okay. So I'm just combining up like terms on this side of the equation. Get this. So now what? This is a quadratic equation, but it's not equal to 0. So I'm going to subtract the 100 over so that I get it equal to 0. And I get 10x squared minus 60x. This is equal to 0, right? The 100s cancel out. Okay. And so now I just want to figure out what x's will give me 0 here, which I can factor this, right? Is there anything that goes into both of these? Well, a 10 goes into both, and there's an x in both. So let's take out a 10x. On this first part, I'm left with an x, and then something times 10x to give me 60x, I need 6. Okay? Is equal to 0. So what values of x will make this work? It would just be, well, where will this be 0? It will be at x equals 0 and x equals 6. Okay? So those are my two values for which this could work. Okay? So this is one part of our problem, right? But remember, when we find x, we're not quite done yet, right? We still have to find y. So that's our final step. So we're gonna, well, I think the book calls this back substituting, right? Okay, so I'm gonna back substitute. I'm gonna take these x's and I'm gonna find out what y is. So the equation that I should use is the one that's solved for y, right? So I plug in let's see, what was our equation? I'll write it right here. Y is equal to negative 10 plus 3x. Okay, so that was our equation that we solved for y. So now I just plug in those two x values to get y. So when x equals 0, what do I get? Y would equal negative 10 plus 3 times 0, right? Just plugging it in for x. So y would be negative 10. Okay? When I plug x equals 6 into this equation, I would get y is negative 10 plus 3 times 6. Okay? 3 times 6 is 18. So we get negative 10 plus 18, y would be 8. Okay? So I have two answers, right? One is negative 10 and one is 8 for y. This one corresponds to 0, this one corresponds to 6. So my final answer is just 0, 10, negative 10, that's 1 point, and the other point is 6, 8. Those are my answers. Okay? So you'll notice the process is very similar. It just can be a little bit longer because you can have multiple points where it intersects. Okay? So let's just review our steps again. For substitution, step 1, we solve for one of the variables. Step 2, we substitute it into the other equation. Step 3, we solve for the variable that we have, which will usually involve you having to distribute something out. Then we back substitute in to get our final answer, what the other variable should be. Okay? So, hopefully that's helpful. I'll show you a graph of the situation, right? Remember this x squared plus y squared equals 100. This is a circle of radius 10. And then this other line that we have, 3x minus y equals 10, it's a line that looks like this. You'll notice they touch each other at 6, 8, which is what I got, and 0, negative 10. Okay? So this is right. What we did actually did tell us where these two things intersect. Okay? Which is pretty cool. We take a complex problem and we're able to solve it just algebraically by messing around with these equations. Okay? Okay, let's do another example now. But remember, I was saying you could use substitution or elimination. Okay? So on that last one I did a substitution, right? This one, let's try using elimination, okay? And to be honest, it doesn't really matter a lot of the time, but there are some times when it's better to do one method than another. This one, elimination, will work because I have the same things on both equations. So it won't get too messy when I try and combine these equations together to get a new equation, right? But if I don't have the same, like x squared and y here, like if they don't really line up very well, the equations, you probably want to go with substitution, okay? So, let's do elimination. And I can eliminate either x squared in the equation, or I can eliminate y. It doesn't really matter. I'm going to eliminate x squared, okay? I'm going to get that out of the equation. So to do that, I need to make these opposite signs and the same numbers so that when I add them together, they cancel out to 0. So what I'm going to do, I'm going to take equation 1, I'm going to times it by, well, to get it to be opposite of this one, I'm going to need a negative, and I'm also going to need a 5, right? So we'll maybe do negative 5 times that top one all the way through, okay? So I get negative 15x squared, okay, minus 10y is equal to, and I need a handy-dandy calculator, 5 times 26, got my pink calculator here, 130, so negative 130 here. Okay, whoa, come on there. Okay, there we go. So I just times by negative 5. This one, I'm going to get it to cancel out, I'm going to times it by, well, on this bottom one, I just need to times it by 3 to make it match up, right? So I'm going to times it by 3. I get 15x squared plus 21y. This is equal to 9. Okay? So, we've got two equations that we've manipulated so that when I add these two together, the x squareds go away, right? And that's the whole point that we were going for here. So let's go ahead and add these together. Those cancel out, and I get 11, 21 minus 10 is 11, y is equal to negative 121, I believe, right? So, 11y equals negative 121. I'm just going to divide by 11 now, and we get negative 11. Okay? So that's our y. So remember, our steps with elimination are, you want to get one of the variables to have matching opposite coefficients, right? So that you can add them together and cancel them out, right? Then you solve for the variable in the equation. And now we just need to substitute in this y to figure out what x is, right? I'm going to plug this back in to one of the equations to find x, okay? So I get 5x squared plus 7 times negative 11, this is 3. Okay? So now I just solved this equation for x. So I get 5x squared, 7 times negative 11 is negative 77. This equals 3. Now we just add 77 to both sides of the equation. 5x squared is 80. Divide by 5. Let's see, 80 divided by 5. My brain does not want to do calculations today, guys. 16. Okay. And now I just square root both sides of the equation to solve for x. But be careful, if you do a square root to solve this, what do we need to throw in? We need to have a plus or minus, right? Whenever you take a square root, you do plus or minus, right? So, and square root of 16 is just 4, so plus or minus 4. So in other words, there's two different x values that work here. Oops, sorry. But only one y value, right? So in the end, my answer from this should be points, right? So I just do my two x values, one of them's 4, the other one's -4, and then I've got -11, -11 are my y values. They both be the same y value. Okay, so that's my answer here, would be these two. Okay, so not too bad, right? It's not too bad to solve these. We just do the same sorts of methods that we did for linear equations. There's just maybe a little bit more going on with these ones than the other ones, okay? If you want to see a graph of that one we just did, here is one for you. So we had 3x squared plus 2y is 26. That's this red parabola here, okay? Since they both had x squareds in them, they're parabolas. And then the y's didn't have squares, so they're just parabolas, okay? So then this other one looks like this. They intersect in 2 points, 4, -11, and -4, -11. We found both of the places where they touch, okay? Pretty interesting. Pretty cool, too. Okay, so let's do just one more example of this with the algebra, okay? Kind of work through our steps here. And then we're almost done, okay? So I've got an equation here. X squared minus y is 2, and 2x minus y is -1, okay? I've got a system of equations. It's nonlinear because there's a square on the x, right? So in order to find where these two intersect, this is going to be a parabola, this is going to be a line. We want to try and either use substitution or elimination, okay? Now on this one, these guys don't match very well, right? This one I have an x squared, this one I have an x. Now you could still do elimination with this one if you eliminated your y, okay? But I'm going to do substitution instead because these two equations don't match very well, okay? So I'm going to do this by substitution. So what I'm going to do is I want to solve for one of the variables in the equation, right? So I solve for a variable. I'm going to use this one because it doesn't have squares in it. I'm going to solve this one for, let's do y, okay? So I'm going to solve for y. We get 2x minus y is -1 is what we're starting with. To solve for y, I'll move the 2x over. So I get -y is -1 minus 2x, right? Then I'm going to divide by the negative on both sides. So I get y is, that'll just switch both of these signs. Okay. Y is 1 plus 2x. Okay? And maybe I'll write up here, I'm using substitution. Okay? So I'm solving for a variable. Whoa, substitution. Should be an S here. I don't have you guys here to correct my spelling. Where are you guys? I need you. Come on. Okay, so we've got y equals 1 plus 2x. Okay. So now what I'm going to do is I'm going to plug that into the other equation for y. So everywhere there's a y, I'm going to put this 1 plus 2x in there. So I've got x squared, right? Minus y. So I'm going to plug in this. 1 plus 2x. Be careful to put parentheses, right? Because the minus goes to all of this, not just the one thing, not just to the 1. Okay? And this equals 2. Okay? So I've got this set up. So I'm going to distribute through my negative on this. We get x squared minus 2x. I'm just going to put that first because that's normally what I do. Minus 1 is equal to 2. Okay. And now I have a quadratic equation. To solve it, I want it to equal 0. So I subtract 2 from both sides. I get This is a -1 minus 2 is going to be minus 3 equals 0. Okay? So, to find x, what I need to do now is try and factor this equation, right? I need to try and figure out what values of x will make this true, so I try and factor. So I look for what numbers multiply to -3, this number, and add to -2. Well, those numbers would be -3 and +1, right? So this would factor as x minus 3 and x plus 1 equals 0. Okay? I'm gonna maybe scroll up here. So what does that mean x has to be? We just flip those signs and we get x is +3 and -1. Okay, so those are my values for x. Are we done? I hope you're all shaking your head vehemently at your camera or your laptop or whatever you're watching this on, saying, no, we're not done yet, Mr. Green. We have to find y too, okay? So what we do is we take our x and we're going to plug that into the equation I solved for y. So I get when x equals 3, what is y going to be? I plug in 3 for y, I get 1 plus 2 times 3, which is 7, right? 6 plus 1 is 7, okay? When I do x equals -1, I plug that in for x. What do I get? I get y is 1 plus 2 times -1. Right? I'm using this equation that was solved for y. So I get y is 1 plus -2 is -1. So those are my two answers. When x is 3, y is 7. When x is -1, y is -1. So we've got 3, 7, and then -1, -1 are my answers. Okay? So what were my steps? I used substitution. So I solved for one of the variables, and then, so that's what we did here. We found out what y was. We plugged it into the other equation, and then we solved for x, and then back substituted to find y. Okay? So, last thing I want to mention before we're done is, what if instead of wanting you to solve it algebraically, what if they just give you a graph and they tell you, find out where they intersect? Well, you just look at the graph, right? If they say solve this system, but they give you a graph, what do? You just give the 2 points where they intersect, and they'll give you nice points if they're going to have you solve it graphically. This would be at 0, 2, and this one would be at 2, 0, right? Those would be our solutions for this system if they gave it to us graphically. Now this system is different than the one we just solved together, so that's why the answers are different, okay? So that's basically what you need to do for this section. It's basically the same as 5.1, just now there can be x squareds, y squareds in your equations, okay? You're just using those same methods though. But I think that's it for today. Hopefully this is a little bit shorter so that you can go, you know, frolic outside or whatever, just don't get too close to people. I hope you have a good rest of the day, and I will see you in the next video. Also, feel free to email me if you have homework questions so that I can make videos on any questions that you're really stuck on the homework, okay? Submit your homework on Canvas. There's a place for you to do that, okay? Have a good one, guys. We'll talk to you later.